Hello and welcome to my channel. For today's video, we will be discussing about rational functions, particularly rational inequalities. If you are new to this channel or haven't subscribed yet, it'll be a great encouragement for me to create more video lessons like this in the future. So please consider subscribing, like, or comment down below. So let's get started. So here are the few methods to remember in solving the rational inequalities. Number 1, write the inequality with a single rational expression on the left-hand side of the inequality and 0 on the right-hand side of the inequality. Number 2, determine the meaningful numbers by setting the numerator equal to 0 and setting the denominator equal to 0. Number 3, use the meaningful numbers to separate the number line into intervals. Number 4, test for the meaningful numbers if they make the inequality true or false. If it is true, then they are part of the solution. If it is false, then they are not part of the solution. To get the value in each interval and substitute this into the inequality, if the test value makes the inequality true, then the entire interval is a solution to the inequality. If the test value makes the inequality false, then the entire interval is not a solution to the inequality. And lastly, express the answer in interval notation. So let's see how simple this is when we got to our examples. So let's jump right in. Okay, so for this example, this is how our inequality should be like before we proceed to further solution. So since on the left-hand side we have a rational expression written in one form, and on the right-hand side we have the 0, so we can now equate the numerator and the denominator to 0. So let's do that. So we have x plus 5 equals 0. And then we have x equals negative 5. And then x minus 7 equals 0. So we have x equals 7. So therefore, we have the values negative 5 and 7 as our critical values. This is not yet our answer. So we will test that later. Okay, so let's test negative 5, whether it is part of the solution or not. So replace back to our inequality, negative 5 plus 5 over negative 5 minus 7 less than or equal to 0. And then the result is 0 divided by negative 12, which is 0 is less than 0. Therefore, this is true. And then let's test 7. 7 plus 5 over 7 minus 7 less than or equal to 0. So 12 divided by 0 is undefined. So therefore, 7 is a false answer. So from here, we will be mark negative 5 since this is a true answer. Therefore, negative 5, let's use solid point on this one since this is part of the solution. And then 7, let's just positive 7, let's just simply use hollow point because 7 is not part of the solution. And then let's test another values. Let's see if we can find another solution. This time around, we will use interval numbers. So let's say, for example, from negative 5 to positive 7. So I am choosing negative 4 as my representation of this interval. Okay? So you may pick any number that you want for you to be able to test whether this interval is a solution. Okay, so by testing, the result would be 1 over negative 12 or simply negative number. So a negative number is less than 0. So therefore, this is part of our solution. So let's mark this one. That means from negative 5 to 7 is included in our solution. Okay, that is true. Okay, so how about 10? Okay, so 10 plus 5 over 10 minus 7 less than or equal to 0. So the result would be 15 over 3, which gives us the answer 5. So it's 5 is not less than 0. So therefore, any number from representing from 7 up to positive infinity is not part of our solution. And then lastly, let's check this one. Okay, so negative 6. So any number from negative 6 or from 5, negative 5 up to negative infinity, if it is included in our solution. So we have negative 1 over negative 13. That gives us positive. So a positive number is not less than 0. So therefore, any number that is less than 5 is not a solution. So this is also false. Okay, so the solution we have here is, so this is a closed interval, meaning to say that the number after or before the interval, the closed interval, is part of the solution. And then the other one, so up to 7, and then from there we use open parentheses. So the parentheses symbolizes not part of the solution. So it is just simply a reference number, but it is not included as our solution. So this is the solution for number 1. On our next example, as you can see, it wasn't yet set as it should be from the methods that we learned. So we will do a bit of tweaking, or in mathematics term, applying the properties of equality. Or we used to use the shortcut that we know, and that is to transfer to the other side. So this number, positive 3, we will transfer it to the other side. And that becomes 2x minus 3 all over x minus 3 less than or equal to 0. And then from here, we have to set this as one term. We have to multiply it by our LCD, which is x minus 3. So x minus 3 is our LCD. We will have to multiply it on both sides. So x minus 3 divided by x minus 3, that is 1. So that is 2x minus 3. And then x minus 3 times negative 3, that is negative 3 times x minus 3. So we have x minus 3 times 0, it's still the same, still 0. So all over x minus 3. So from here, we can simplify this term. That gives us 2x minus 3 minus 3x plus 9 all over x minus 3 less than or equal to 0. And then from here, we can combine like terms, and that will also gives us negative x plus 6 over x minus 3 less than or equal to 0. Now, we can use now the inequality which equate both numerator and denominator to 0. So negative x plus 6 equals 0. So that becomes x equals 6. Now, for the denominator, x minus 3 equals 0. That becomes x positive 3. So our critical values are 6 and 3. So let's test if 6 and 3 are part of the solution. So let's have first number 3. So by replacing to our inequality, so 2 times 3 minus 3 over 3 minus 3 less than or equal to 3, that becomes 6 minus 3 over 0 less than or equal to 3. Since this is undefined, therefore, 3 is not part of the solution. How about 6? 2 times 6 minus 3 all over 6 minus 3 less than or equal to 3. So we have 12 minus 3 divided by 3 less than or equal to 3. That gives us 9 over 3, or simply 3 over 3. So therefore, 6 is part of our solution. So from here, 3 is not the solution, so we will use hollow on this one. And then since 6 is part of the solution, therefore we will use solid point. So those are the reference value that we can use for our next solution. Let's proceed. Now, from here, we will now test all the interval numbers if we can get solutions as part of our intervals. So let's test for those solutions. Let's say, for example, we use number 5 in between 3 to 6. Okay, you can choose any number. So this time around, we will use 5. So let's substitute that to our inequality. Negative 5 plus 6 over 5 minus 3 less than or equal to 0. And that will give us 1/2 less than or equal to 0. So 1/2 is not less nor equal to 0. So that means any number in between 3 to 6 is not part of our solution. Next, now let's test 1. So any number from here will be a good substitute for our testing. So this time around, I will be using 1. So say for example, we substitute that to our inequality. Negative 1 plus 6 over 1 minus 3 less than or equal to 0. That gives us negative 5 over 2. So negative number is less than 0. Therefore, that is a true solution. So that means any number from negative infinity up to 3 is part of the solution, excluding 3. Say for example, we have now from 6 to infinity. Let's say for example, let's use 10. So negative 10 plus 6 over 10 minus 3. So remember, our example is 10. Our test value is 10. It becomes negative because our inequality here is a negative symbol. Okay? So let's continue. The answer is also a negative number, negative 4 over 7, which is also true. So therefore, from 6 up to positive infinity is part of the solution. Now, so from here, since from negative infinity to 3, that is a solution. So from negative infinity, we will be using open interval since there is no exact representation for the infinite number. And at the same time, 3 is, after 3, we use open parentheses or simply open interval since 3 is not part of the solution. Together with or union with, since 6 is part of the solution, we will be using closed interval and then up to positive infinity, and then we use again the open interval since we have no exact number or representation for the infinity. And this will be our answer for example number 2. Okay, now on our example number 3, if we're going to look at our denominator, 1 plus x and x minus 1 is simply equivalent to the LCD, that is x squared minus 1. But if we're going to take a look on our second term, the LCD must be x squared minus 1, but we have an additive inverse on the second term. So this one. So to become the LCD, we should be multiplying by negative 1 or factor out negative 1. It's just the same thing. So say for example, we have negative 1 outside this parenthesis since this is the additive inverse of our LCD. So therefore, we cannot have positive and negative 1 to be included on our LCD. Okay? Now, let's solve this problem. X squared minus 1 divided by 1 plus x or x plus 1. That will give us x minus 1 times 1. So we have x minus 1. And then x squared minus 1 divided by 1 minus x squared. That will give us negative 1 times positive 2. That will give us negative 2. And then less than or equal to x squared minus 1 divided by x minus 1. That will give us the answer, x plus 1 times 2. That will become 2x plus 2. And then to continue, so this will become x minus 3 because we will remove this parenthesis. And then we will simply combine the terms, x minus 1 minus 2. That becomes x minus 3. And then we will just simply copy the next term. So less than or equal to 2x plus 2. And then from here, we can now combine like terms. So 2x, let's put it on the other side, and then 2, let's put it on the other side. That will give us negative 5 less than or equal to 5, or x. So we can write this now into an equality symbol. So x plus 5 is greater than or equal to 0. And now we will have this form, x plus 5 divided by our denominator, or LCD, greater than or equal to 0. And then we can now equate the numerator and the denominator to 0. So we will have x is equal to negative 5, and then x is equal to positive and negative 1. So these are our critical values. Okay? So on our number line, we will be marking if negative 5, positive 1, or negative 1 is part of our solution. Since we cannot have positive and negative 1 as part of the solution, so therefore we will exclude this number. So instead of solid point, we will be using hollow point for negative 1 and positive 1. How about negative 5? So let's test that value. If x is negative 5, so negative 5 plus 5, that's 0. So this becomes 25. The denominator becomes 25 minus 1, that's 24. So 0 divided by 24 is equal to 0. So therefore, negative 5 is part of the solution. So therefore, we will be using solid point. Okay? Now, let's test some interval. Since negative 5 is part of the solution, and negative 1 is not part of the solution, say for example, we will be using 3. Okay? Negative 3. So negative 3, let's replace this, negative 3. So negative 3 plus 5, and then negative 3 squared minus 1. Let's see if this equal or greater than 0. So this becomes 2 divided by 8. So that's 1/4. So 1/4 is greater than 0. So therefore, between this number from negative 5 to 1, it's part of the solution. How about in between negative 1 and 1? Say for example 0. So let's remove this number. That becomes 5 divided by negative 1. So a negative number is not greater than 0. So therefore, in between this number is not part of our solution. Okay? So how about this number? So from negative 5 to negative infinity. So let's have that one. Say for example negative 6. Okay? So negative 6 plus 5 divided by negative 6 squared minus 1 greater than or equal to 0. So negative 5, negative 6 plus 5, that gives us negative 1. And then 36 minus 1, that's 35. So this is a negative number. So therefore, from negative infinity to 5 is not included, also not part of our solution. So how about from positive 1 up to infinity? Say for example, if this is part of the solution, say for example, let's use 5. So 5 plus 5, that gives us 10. And then 10 times 10, that's 100 minus 1, that's 99. So 10 divided by 99 is a positive number, therefore greater than 0. So meaning to say, from positive 1 up to positive infinity is part of the solution. So for our interval notation, so we have closed interval, negative 5, since negative 5 is part of the solution, so we will use closed interval up to negative 1 and then open interval. Union with from 1, so that's open interval since it's hollow, up to positive infinity. So this is our solution for letter D. Okay, now let's take a look on our last example. So since it's our last example, the solution here is not in detailed form since you already know how to do it in your own terms. So we have x over x plus 3 minus 3 over 3 minus x greater than x plus 9 over x squared minus 9. So our LCD is x minus 9. So we can't afford to have positive and negative 3 as part of our solution. Now let's divide it back to our original expression. We will get the result x times x minus 3. And then on the second term, so we also have an additive inverse of 3 minus x. That is x minus 3. So we will have now negative 1 as our factor. So that gives us positive 3 times x plus 3 greater than x plus 9, since we divide the LCD by itself. Okay, so let's distribute this number. We will get x squared minus 3x plus 3x plus 9 greater than x plus 9. So let's combine like terms. We will remove that one. And then we left with x squared plus 9 greater than x plus 9. So let's combine like terms. We have x squared minus x greater than 9 minus 9. We factor out x, so that x times x minus 1 greater than 0. And then we will have our critical values, that is 0, 1, and positive and negative 3. Now, if we're going to test all the numbers or the possible answer back on our inequality, we will see that we will get this answer from negative infinity to negative 3. Okay, so negative 3 and positive 3 is not part of the solution. Also, 0 and 1 is also not part of our solution. Therefore, our solutions are from negative infinity to 3, union from 0 to 1, union from 3 to positive infinity, and they are all written in open interval notation. Okay, so go ahead and pause this video if you want to try the problem. Okay, so let me show you the answer. So the answer for number 1 is from negative infinity to 5, union from 10 to positive infinity. Answer number 2, from negative infinity, including 15 over 8, so that's closed interval, union with open interval, negative 3 halves, to positive infinity, close open interval. And then lastly, for number 3, we have from negative infinity to negative 1, which is also written in open interval. So thank you very much for watching. Hope this video helps, and see you again on the next video. Hanggang sa muli, God bless us all.